You're listening to the Chorus One podcast, a show that covers decentralized networks and their impact on the evolution of automated and borderless economies. On this podcast, we invite pioneers and builders to discuss the decentralized protocols and projects they are working on. On the podcast today, we have Ganesh Swami, founder of Covalent. Covalent provides a unified API bringing visibility to billions of blockchain data points. As of March 2022, there are over 500 cryptocurrency projects using Covalent's API. Right now, Covalent is in the process of decentralizing the network to make it trustless. Block specimens such as Chorus One play a vital role in keeping the integrity of blockchain data to be used by all of the projects using Covalent's API. We speak with Ganesh about Covalent's product, use cases, token economics, decentralization strategy, plus so much more.
Hello and welcome to another episode of the Chorus One podcast. Today I'm here with Xavier, my co-host, and Ganesh Swami, the co-founder and CEO of Covalent. Welcome, Ganesh, and hi.
Felix, Xavier, excited to be here.
Yeah, so why don't we start with a little bit of introduction to you? I guess Covalent is a blockchain network. Chorus One, we are also supporters of Covalent and been following you for a long time. I think that doesn't necessarily apply to our audience, so it would be great to hear a little bit of your background, what brought you into crypto, and then we can talk about Covalent later.
Absolutely. So Felix, I got my start in the pharmaceutical sciences, so building cancer drugs, and I spent about half my career building drug design models. And I found that industry to be really slow. And so I pivoted to the big data space about a decade ago. And I've been doing scaling and database engineering work for the past decade. About 4 years ago, just for fun, I showed up at a blockchain hackathon. And I built this middleware connector that lets you speak SQL to the blockchain. So just from my experience in the database world, the world had converged on SQL as a language to speak to databases. And I thought it would be cool to have blockchains speak SQL. So now you can connect the entire array of traditional tools, Excel, Tableau, all of your programming languages, to this newfangled technology called blockchains, and it'll be cool, right? So it's like you index the data and then you just speak SQL, and ended up winning that hackathon. And then we decided to start Covalent from that hackathon. So that's the genesis story of Covalent, and the word covalent comes from covalent bonds in chemistry. So my apologies to your listeners for those harsh memories from high school. But here we are binding centralized and decentralized systems or databases and blockchains. So today, Covalent is a unified API to pull out all kinds of blockchain data. So balances, positions, historical granular transaction activity across 32 different blockchain networks. So the magic is one interface, all blockchain data. So we normalize and canonicalize all of the data, which I'm happy to expand upon further in the podcast.
Maybe one first question I have, and thank you for the overview, is so when you were building Covalent, this API, who did you have in mind and who were you building it for?
So there's been a couple of pivots along the way. We didn't have an API from the get-go. What we had built was an analyst product and a middleware connector. So you use something like Tableau or Excel to do reporting or compliance. So that was the initial audience. But back in 2019, there was no market for that kind of product. So in the search for product market fit, what we found is a lot of wallets, a lot of DeFi protocols. Those are the use cases that we found traction. So then what we did is we latched on an API so that all of the dApp developers, the Web3 developers in the space can just use Covalent just like any other traditional REST API. So that is how we found our initial product market fit.
And do you expect these parties to stay the main users of the Covalent API, or are there other kind of consumers that you would expect in the future to also
Absolutely. So today the API is primarily a developer's product. So you need to be a programmer to integrate with the API. And these programmers come from a variety of different backgrounds, right? So crypto native projects that are completely just building, with crypto data, crypto networks. So that's one use case. But we're seeing more and more traction with traditional Web2 companies adding a Web3 component to their experiences. So if you think in the next 5 years, any of your existing mobile banking experiences will have a section for your digital assets like your NFTs, maybe some stable coins. And there, the Covalent API is just a natural fit because it has a wallet balances API or a historical transaction API. So we see a mix of both, but increasingly the traction is coming from Web2 programmers, Web2 products trying to build a Web3 experience because they come with their 50, 100 million monthly active users, and crypto native projects are not at that scale just yet. So that's the developer experience, but we are also cater to analysts, like people who are not programmers and require the data for doing any kind of downstream analysis, either compliance or risk analysis or staking income or taxes. So there, you don't necessarily have to be a programmer.
So I just want to touch upon that just quickly. So, in particular interest to me. So as someone potentially, that is an analyst, but perhaps doesn't have the strongest technical background, how or what would be required of me to use a product like Covalent?
So we have an initial product with the API. So if you go to the API docs, there's something called the analyst mode. So what happens is suddenly all of the request responses become like an Excel spreadsheet-like experience. So you just have grids, you can copy paste, export a CSV, export to Tableau, Data Studio, all those kinds of tools, right? So we let you use the API. In fact, last year we had a couple of hackathons called Dungeons and Data, which is literally a data hackathon. And there, you don't need to be a programmer. You just have to go crunch the data and do all kinds of analysis. So it's a very popular hackathon. But we are building other kinds of experiences, more ways to consume the data. The data, underlying data, there are lots of ways to consume it. So we are building an analyst experience, which, it's still early days, but that's a big audience for us as well. So we'll share more on that later this year.
All right. I guess we can start talking a little bit about Covalent as a network, right? Which in the end it is. You kind of touched upon it, like this canonical representation of blockchain historical state. Can you maybe explain why is that needed and how Covalent does that?
Great question. So let's take a step back and understand what is the core challenge or the core issue at hand and why services like Covalent need to exist. So if you look over the last 4 or 5 years, the majority of the focus has been on the right scalability of blockchains. This is why you have lots of layer 1 chains, layer 2 scaling solutions, all kinds of side chains that are boasting about their transactions per second or their settlement rates and that kind of metrics. But an often overlooked aspect of blockchains is the read scalability. So you're having all this like really interesting, rich data on blockchains, but how are you going to extract it and use it for downstream purposes? Like it needs to coexist with existing infrastructure. So the read scalability issue is essentially what we're attacking head on. So we've never wavered in our vision over the last 4.5 years. So the read scalability is it just unpacks a whole bunch of systems that need to be rethought from first principles in order to scale just consuming that data. So there's like the RPC layer, there's the storage layer, the blockchain nodes themselves, the canonical storage layer, the downstream formatting of the data, the consumption of data for other kinds of services like Excel. So that entire pipeline is what we've been refining over the last 4 years. So happy to jump into any specific aspect, depending on interest.
Yeah, so I think perhaps what might be interesting to hear from you is, so the network itself, we sort of touched upon what it does. But there are, of course, some ecosystem actors that you have, and there's actually quite a few in Covalent, which makes it quite unique, I guess, compared to some other networks. It would be great to hear the types of ecosystem actors and what they do in your network.
Absolutely. So the general premise behind these indexers is a concept called ETL. So extract, transform, load. So you extract from a blockchain network, you transform or canonicalize that data, and then you load it into another data store that is purpose built for your downstream applications, either for analytics or a wallet use case or a taxation use case or a compliance use case, whatever that use case is. So that's generally the premise. And we've built this pipeline over the last 4 years, and it's been in production, serving billions of queries and thousands of developers, and it's production grade code. Now we're taking this step to a decentralized network through a progressive decentralization story. What that means is every step along the way, we are making it trustless to the maximum extent that we can, right? So the first step we're going to do, we're going to launch as early as Q2, is what is known as the block specimen producer. This is the essentially the problem statement is that how do you get a network of untrusted parties to extract data from the blockchain and continue to keep the sanctity and the integrity of the blockchain data. So here we have, to my knowledge, one of the only proof-based systems where you're able to extract data from a blockchain, and the proofs is what keeps all of the players honest. So this is the only system that, to my knowledge, is solving this problem. No other indexer out there has a proof-based data extraction pipeline. So the advantage of this is now that you have a proof of what the data and what the block and all of its constituent elements is, if the proof does not match, then you know that there's some kind of corruption in the underlying extraction process, either maliciously or accidentally, right? A lot of these corruption issues are just like double signing, are not malicious, they're actually accidental. So this is how you keep the sanctity of the data in. And then once you have that block specimen, which is our own, which is Covalent's canonical storage format, now you can use it for downstream purposes. So let me dig a little deeper into why we're doing the block specimen. So the blockchain node is a very complicated piece of technology. So this is something like Open Ethereum or Parity or Geth. So Geth is the most popular Ethereum node that's out there. And if you look at every EVM chain out there, be it Polygon or Avalanche or Binance Smart Chain or Phantom, they have one aspect of like Geth. So there's this small team of like 6 or 7 people that's been delivering billions of dollars of value. So kudos to the Geth team. If there's a Gitcoin grant for the Geth team, please contribute to that. We're huge supporters of that team. They're under a lot of pressure, and they're supporting the entire network. Everyone is basically a fork of Geth. So the node itself has a storage layer. So there's a database there. There's a consensus algorithm. There's a networking layer. There's a lot of moving parts, lots of pieces. So it's actually quite complicated, quite intertwined. So by extracting the storage layer separate from the consensus and the network and block execution layer, what you can do is you can do a lot. You can just scale it a lot more. So the block specimen, what happens is that we've extracted the block and its transactions and its receipts. And now that you have the storage of, you basically have the data, and you've deleted all of the consensus and the block execution, you can do whatever you want with the block specimen. You can rerun a tracer, you can enrich it, you can join it with external resources. So now this is a standalone piece. And the magic here is that if you have a sequence of block specimens, you can rebuild the entire blockchain without using the node. So that's really what the magic is. So our vision behind the block specimen is to make this standard open. It's an open standard. It's all open source. It's available on our GitHub, and the specification is also open. The reference implementation is all open. Is for every network out there to implement the block specimen. So we are starting to see other nodes adopt this protocol. I know there's work underway on the Near protocol and Elrond. So suddenly this world, the Web3 space, will have nodes emitting block specimen, and then you have the whole array of tools that consume the block specimens, runs a tracer, does an enrichment step, whatever it is. But this is like it's a public good, so everyone can consume from this. There's also a secondary benefit from this. in the world of audit and compliance, the tools and the teams that you use for audit cannot be used for compliance. It just like that just doesn't make sense. But some tools are anointed as standards, like Excel. You can use Excel for compliance, you can use Excel for auditing, right? So by having the block specimen and its proof as a standard, as an open standard, our vision is the compliance and the audit industries use the block specimen as a standard because it's an open, neutral standard that's backed by mathematics and cryptography, not by someone's attestation. So I think that's the overall vision behind the block specimen.
That sounds super cool. So that's, I guess, another group of users that we actually also didn't really talk about, potentially, like the audit system. I think it's also right where a little bit Dune Analytics pitch is always like, it's not going to be like quarterly reporting, but like real time. Is that also something that will be enabled by Covalent? I'm assuming, where really you could audit things like directly versus like having to wait for a quarterly audit or something. Is that correct?
Absolutely. So we work at a layer below Dune Analytics. So Dune Analytics is this viz layer, the visualization and the modeling layer. But if you were to ask, how does that data get into Dune's database? That's not a proof-based system, right? So if there's any mistake in their pipeline that gets to that destination before you can model it, then you have no recourse. So if you use something like Covalent, where every step along that data supply chain has a proof-based system, and our hope is, vendors like Dune adopt the Covalent proof-based block specimen. In fact, we've open sourced some patches to the Solana node, and we're just waiting for them to be merged. And I think this will just elevate the entire space. So it's not just for Covalent; it's all of our friends, all of our competitors. I think the Web3 space is too nascent to really, talk about competition, to be honest.
So I think, I guess I don't want to get too far ahead, I guess, and thinking about the future. But it sounds like you could be potentially this sort of interconnected between a lot of different networks. I'm not sure if this is in your plans or how you think of it, but like interoperability, let's say you have this block specimen on Solana and that is a proof of the state at some time, and you also have that across many different networks. Are people building on top of Covalent, for example? Like you mentioned June just before, which, you can use Covalent data to produce these graphs. Are you planning on it just being like this API where you sort of use it for analysis and auditing, or can it also be this interoperability layer where you can also move assets across using the block specimen?
No, we would never go to the write aspect. We would never change state, right? That's just outside our purview. We are 100% laser focused on just the read aspect of blockchains. So bridging, moving assets, none of those things are within our roadmap. That's just outside scope. So we would never do anything like that.
Maybe I actually wanted to get back a little bit into this proof-based system, since I guess a lot relies on that being correct, and you have like these decentralized actors that we said that create the block specimen. Now, can you maybe explain a little bit economically how that works? And there are these different block specimen producers. If there is someone that has some mistake in there, how is that checked? Like, who checks that? And what is the recourse for someone like trying to produce a fake or like a wrong thing here?
Great question. So we are undergoing a progressive decentralization story, which means that the full feature set with slashing and all that is not enabled from the get-go. We want to scale this up. So if you think about the network and all of the different phases, there's a supply side and there's a demand side, right? The demand is the consumption of what the supply side generates. And the matchmaking is the market clearing price. So that's how any network works. So here, the block specimens, you want to incentivize them to create these proof exports, but not too much, not flood the network with these proofs, because then you have an abundance of supply and there's no demand, downstream demand, right? So you just need to match it along the steps, right? So here, what we have is a very simple system. So if you have, let's say, 10 operators who are creating the block specimens, we split that into essentially auditors and block specimen producers. So not every operator will generate a proof for every block, right? So it would just be like a randomized set. And what you would do is you would ensure that the proofs are consistent with the auditors. So let's say you have a group of 10 operators, you pick two auditors, and then you have eight operators creating the block specimens. There's technically no difference between an auditor and a general like block specimen producer. They're also producing the proof, and then you look for a quorum and a consensus there. So there, if everyone is in agreement, great. If one person is not in agreement, then there's a problem. If the auditors are not consistent, then you have a problem, right? So you can draw a flow chart of all of the possible states, and and so there's no slashing. So what happens here is there's just a risk of opportunity cost. So if you produce a block specimen that is invalid, or you fail to produce a block specimen, you don't necessarily have to produce a block specimen for every block, right? You can participate like once a day if you wanted to. Then all you do is you just don't earn the rewards for that block specimen. That's all it is. So it's a very simple kind of system for V1. And our goal is to do breadth first, get the like phase 2, phase 3, phase 4, and then go back and then improve the economic model, because it's very difficult to over invest in one stage of the network while the other phases are still proof of concepts.
Yeah, that makes a lot of sense. I guess just for understanding again, sorry that I'm going into this a bit more, but I guess so we have some people creating the block and then the auditors, and then is the network somehow comparing if all of these are in consensus? And if they're not,
Absolutely.
Essentially it's assumed that the one is invalid, but he just doesn't earn anything. So
Exactly.
like the majority wins, and by that everyone is kind of incentivized to produce the right solution, because that's what consensus will turn out to be anyway.
Exactly.
And is there a certain amount of, so you talked about decentralizing the network in general, is there some number of node operators you'd be targeting to sort of make sure it's sufficiently decentralized, or does like latency have any impact on your network itself? Like, is there sort of an optimal amount of operators you would like on the network in future, or it's just open to?
So we are taking a model-based approach to this problem, right? It's very difficult to hypothesize what is optimal without having a model that's backing it. So in the model, there are two dimensions to this problem. The first dimension is how many operators is sufficient to meet quorum, right? If you have one block specimen and one auditor, that's not sufficient, information to be confident about the block specimen. So that's the number of operators that you need. The second dimension is how many networks are out there, because the same kind of system can happen on Polygon, can happen on Avalanche, can happen on all the others like subnets, that can happen on like Evmos, like all chains, right? So there's like multiple parallel universes of block specimens. And currently, all of the incentives are coming from an inflation-based incentive layer from the CQT network. So there, it's a matter of balancing how many block specimens that we need, and how we're going to vertically or horizontally scale the block specimens so that we're in line with the incentive models. So that's really what the model talks about. So these are tweakables. You can build an Excel spreadsheet. You can figure out, what is optimum, what is not optimum. How do we have performance incentives? But our design is always to go back to a model and not just have ad hoc toggles, right? Because then it becomes very confusing. You don't really have a strategy behind tweaking the model.
All right. Yeah, trying to figure out where we go from here. Definitely extremely interesting so far. I guess you kind of mentioned the inflation just now. I think that's maybe a good point to touch upon, where, of course, I guess that's a problem that's in many networks, basically all crypto networks, that like most of the activity is kind of subsidized by token inflation to some degree. But then like many have plans to introduce some kind of fees. Is that the same for Covalent? And
Yeah.
how would that model work? Who's paying for what here, and how?
It's a great question. And I think this is where I would disclose that I'm ultra bullish on Covalent. And I'll tell you why. Of course, as a project creator, I should be bullish, but I have proof to back my bullishness. So Covalent has a tremendous amount of demand side traction, right? So 20,000 devs, thousands of applications using the API, billions of API calls, every month. So it's a pretty massive kind of network that's out there on the demand side. So most networks out there, when they launch the network, there's no demand for block space or whatever that they're creating. So they need to have incentive-based models in order to keep to bootstrap the network, right? Which is fair, right? And if you look Cosmos or any system, even Ethereum for that matter, has the inflation-based schedule, and then the schedule dictates that the inflation drops. So this is where the halvening or the different factors that Ethereum has with the burn, the fee burn, or with the merge, there's going to be another factor in issuance. So lots of things that scale down the inflation-based rewards and have the fee pick up, right? So there's a transition crossover point. So in the case of Covalent, we've made a choice to introduce an artificial deadline on our team and on our ecosystem. So if you look at our token issuance schedule, the inflation-based rewards, they stop after 4 years. That's it. So roughly 8% of the supply is dedicated towards these bootstrapping the network through inflation, and that stops in 4 years. Now, I think that if you're not able to get your network profitable in 4 years, then you have to rethink the problem. Maybe the problem that you're solving doesn't have product market fit, right? And this is counter to what other crypto networks do. They have infinite inflation. And in our case, we shut down the inflation. So our goal is to make the network profitable and make it sustainable through fee-based structure, which is on the demand side. And today, if Covalent were a centralized company, we would be making, eight to nine figures in revenue from, just the application fees. So converting all of that to on-chain, our hypothesis is that you would not need like a 10-year inflation schedule. I would say these networks, of course, something like Ethereum has more traction, something like Polygon has more traction, but something like Evmos, the fee structure is not going to make sense because it's a very new network, right? It just was just launched like last week or just a couple of days ago. So that is essentially our thesis. So the inflation will scale down and the fee structure will pick up. So if you look, the people who consume the API will pay the network, and that fee will go directly to the validators. It belongs to the validators or the operators who service those requests.
And maybe just on the fee mechanism itself. So would someone be paying a fee per query, or are there different types of fees that one would pay, or is it all the same, or how are you sort of seeing that?
It's a great question, Xavier. So we've made a conscious choice here to price the demand side in stablecoin. So our experience comes from enterprise software building, right? So if you look at an enterprise, they want to pay for a service like Covalent, just like how they would pay for Amazon Web Services or Google Cloud. They want predictable billing. They want, they want to be able to budget for it. They want like forecasting capabilities. So they're pricing it in stablecoin as opposed to CQT or any other token makes a lot of sense, right? You don't want to expose them to currency risk. That's what it comes down to, right? So there, the risk is actually taken on by all the network operators, right? And so that's how we're pricing it. So here it will be priced per API call, right? So it will be like a credit-based system. So let's say one API call is 1,000th of a cent. Then as you accumulate your API calls, you would just have a deposit of USDC or some other stablecoin that is then depleted to match with the usage of the product, so of the API. And so all of that funding would go on-chain through a market buy mechanism. It would be converted to CQT and then distributed pro rata to the people who serve the queries. So that's how the system works. So on the demand side, it's stable, right? It's never fluctuating. So all of the risk, all of the variance, all of the volatility is taken on by the operators. which is how it should be, and which is what is fair for if you're looking for these enterprise contracts to come onto Covalent.
Makes sense. And then block specimen producers, or like the people that are serving queries, we mostly talked about the block specimen producers, right? But there's also other roles in the network. And I guess normal CQT holders can also participate in this economy. Can you explain a little bit how that works?
Absolutely. So there's three phases after the block specimen. So block specimen is extracting the data, creating this canonical storage format, and then we have essentially the indexing nodes that run a tracer, capture the information, maybe join with another store, and then you have the storage nodes, and then you have the query nodes, right? So the query nodes are very interesting. The query nodes are basically the Covalent API, but running as a decentralized cloud or a decentralized network. So if Chorus One were to run the query nodes maybe in Berlin and maybe in Frankfurt and maybe in London, then all of the clients connecting from Europe will connect to one of those query nodes, right? And they would all pay stablecoin and so on. And then step by step along the way, what would happen is that stablecoin is converted into CQT, and then every step along the way, it's distributed based on the amount of work that you do. So in this case, if Chorus One's fee is 10%, for numbers' sake, then what would happen is 90% would be given to the delegators, and then 10% would be kept as a fee. So that's generally how the system works. So the delegator, we want to make this like super simple. We don't want our token delegators to even think about optimizing fees or doing anything of that nature. So they would just have one contract that they would deposit or delegate to, and it would be per operator. So if their loyalty is with Chorus One because of some kind of business arrangement, or because they like your culture and your philosophy,
because of the podcast.
Hopefully. Because of the podcast. No, so it's not a joke, right? I think a lot of the space is you like the founders, you like the people, you like their long-term vision, right? You like the other kinds of products that you build, like Anthem, for example, right? So these things, people do care about these things. It's not just financial numbers at the end of the day, right? It is a personal relationship. So it's actually how we picked our operators too, right? We did our due diligence, and we align ourselves with certain operators, and therefore we pick them, right? And so when token delegators come to Chorus One and delegate, they delegate against Chorus One, but then we're not asking the token delegators to go and figure out what role or what blockchain or anything of that nature, right? So in the case of another example is the graph, where you need to signal against a subgraph to pick out. So you need to see what traction, what the fee structure is for each subgraph. It's very complicated, and we want to keep everything super simple. Like our entire philosophy is keep everything super simple, hide all of the nuances under the hood, right? Like the API, for example, the API can be used from the browser, right? We don't ask you to download or write code or anything. So that's really our product philosophy. Likewise, on the token delegation side, you go in, you see the list of operators, delegate it to Chorus One or someone else. You know the fee structure; it's all transparent. But you're not asking a token delegator to choose what network or choose what role or provision or split or look at the fee structure. None of that stuff. Everything should be just transparent and very simple.
This work, let's say, that we're trying to abstract, that is now carried out by the operators. So they have to choose like which role they're going to fulfill and which networks to support. And that will also impact in the end, though, the return that they're going to make for their delegators too, right? So
absolutely,
there is some expectation that the node operator's performance, I guess that will be the differentiator, where maybe you'll earn more with someone that chooses the right parameters here.
There's two kinds of elements here, right? One is the actual fee distribution. So the entire network runs in terms of epochs. And after each epoch, we have the option of rebalancing the fee distribution. So the fee distribution is the actual fees from the demand side that the operator, the queries that are being served, plus the inflation-based reward. So right now, for the 4 phases, it's 25% of the inflation. The emission rate is given 25, 25, 25, 25. And we find that the query nodes needs to be buffed up. Then we would just, rebalance that. Those are the system parameters, and that will have to go through a governance vote. So as simple as that. And our goal is to make it like electricity, right? Super simple. You go in, tap in, plug in, you have network data. And this is where we rely on the technical expertise of a team like Chorus One.
And I'm sorry if this question's already been answered, but in terms of delegations, so I guess doesn't matter how many delegations one node operator would get, essentially all node operators would still be doing the same work with the proofs.
For the block specimen, no, the rewards are always pro rata based on your stake, right?
Okay.
Yeah. And so there we have a couple of controls. I think the biggest risk with these proof of stake systems is centralization, right? Even though it's a decentralized system, you have the ratio, the Gini coefficient, or the ratio between the biggest and the smallest is so wide. So here we have natural limits. All of this is documented on our website. So in the sense that if you have, X dollars or X CPT of self delegation, then you can get 10X that in terms of token delegation. That's the cap. And there's an overall ceiling on the entire system. So our goal here is to scale it up gradually so that we let, everyone level up. Otherwise, what would happen is you go in and, the people who are the biggest will get the most delegation, because most sorting is based on the size of delegation. And then, you can have all these things which are counter to the success of the network long term. So our goal is to gradually roll this out. And of course, your rewards, all of that is pro rata based on your self-delegate plus your token delegation.
Cool, yeah. So I guess moving on to, well, first of all, I guess just to sum up that sort of section, I think it's really terrific. Token economics in general, I think it's very unique and totally different to, I think, anything else we've seen before. So thank you for sort of summarizing, I guess, some of the main points there for how unique CQT is compared to some other tokens. And as you heard before, to anyone listening in now, that, I guess if the co-founder is bullish on the token, it's always a good time to get involved with the project. But I think maybe just, I guess, quickly, just talking about moving back to the sort of, I guess, what the node does and the node provider and the block specimen. And I guess one thing I came across in the white paper, which I think is sort of interesting to think about, is this proof of creation and validators mining this proof of creation that you sort of talked about, I guess, in the white paper. So when I think about Covalent as someone that's non-technical, I'm sort of thinking it's an API that I can use. You're sort of, storing a lot of the data across many different networks. And you've mentioned before that it's completely read and it's not write. So you're not doing things like interoperability. So I guess in terms of so when I look at some of these middleware networks, a lot of it is to do with streaming, something that we haven't really talked about a lot in this podcast yet, which would be great to sort of hear, I guess, your words on. So if I don't know anything about, for example, streaming, what is this? And, how, I guess, touching upon the database sort of side of Covalent, and how is that your specialty versus what's already existing and out there right now?
This is an extremely interesting question. And I've always had this lingering thought behind Covalent is that we're not reinventing a database, or we're not reinventing a node. What we've invented is a streaming protocol, a replication protocol. So how do you keep two data sources in sync in a trustless fashion? How do you have a trustless feed? That's what it is, right? So in some sense, all of the databases, the analytical databases, the indices, the node infrastructure, all of that is just off-the-shelf components, right? Everything has been built before. It's all open source. It's just regular Postgres or regular Get. So what this whole replication protocol is, how do you have a secure feed? So in that sense, this feed can be video stream. It can be, baseball scores. It can be anything of that nature, right? So I would say that's, a 20,000 foot view of what really Covalent is. If you distill it down to the core piece of what makes it novel, right? So to my knowledge, no one has a proof-based secure feed system in production. So that's really what it is.
Yeah, I think that sounds like so much more. Also, I mean, in a way, that could also be used as Oracle data input for applications, maybe that rely on some data. Again, is that a correct assumption? Let's say, you're saying, baseball prices or scores or whatever. I guess if there's some betting application, could that somehow rely on the Covalent data directly, in your opinion, or?
Yeah, so we do have some use cases with which is like an Oracle. There are specialized players like Chainlink that have been working on this problem for years, right? So we delegate that responsibility to Chainlink because they have a economic penalty system for fake data. So here, an example where this could be an Oracle is if you take prices where the price discovery happens on one chain and take it to another chain. So that's an example of like an Oracle-based system because everything is like proof-based, right? If you use something like Uniswap, Uniswap has the AMM model has a price engine built in, so you can literally use one of the Uniswap pools as a pricing engine, and now you can use that asset pricing and move it to any other database. So it's not entirely external data to internal systems. It can be internal to internal systems too. So there, it's a good use case. But specific for the Oracle, we're not an Oracle. We're the opposite of an Oracle. And so, in fact, you see in a lot of these hackathons, people wrap Covalent and Chainlink. So we'll have a template coming out in the next couple of weeks where you can wrap the Covalent API call within a Chainlink operator and use that as an Oracle. So you're matching the secure proof with the penalty system of Chainlink, and have the full benefits of like a secure feed. So people are doing that. I don't know if anyone is doing it in production, but definitely in hackathons, I've seen a lot of these examples. And this is where you get into the all the edges of what's possible, and it's too hard to keep up because you have like thousands of devs building all kinds of novel use cases, which I guess is what makes it exciting, right?
And this is a bit of a bonus question, but it's something that I think is also really interesting that Covalent is perhaps aspiring to achieve. So I saw, I guess, like going back to the database sort of thing. So you have decentralized networks and storage on these decentralized networks, but you also mentioned, or from what I've seen, you can also sort of plug into some more centralized servers, like you've got like Coinbase price feeds, for example. I guess what's a use case that you might expect or could forecast in the future where you're sort of marrying some data sort of in, maybe if it's Coinbase or Binance, with like, I guess, the on-chain and the off-chain stuff like coming together? Have you seen any use cases like that people are working on at the moment?
So not exactly that use case, because that would be the Oracle use case where you bring off-chain price feeds on-chain. So that's something like Chainlink would specialize. But where we think there's a lot of interest in the future is joining public ledger data, blockchain data, with private private proprietary data sets. So you can join the data that's on a public ledger with internal PII data. So if you look at the example with pharmaceutical sciences, the crystal models, your X-ray models of your proteins, for example, that's intellectual property, and that can never be put on a cloud. They can never be put on a public blockchain. But you still need data that is on a blockchain. Okay, let's say it's supply chain data or whatever that is, right? So what you need to do is you need to do that join between these two data sources within the confines of your firewall, or use like a zero knowledge based system. So that's really how we see ourselves extending Covalent, because a lot of the PII data, the personally identifiable information, can never leave your confines of your firewall. Here in British Columbia, which is the province we're in Canada, medical records, patient records cannot leave the province of BC. That's just the rules. So you can't put it on Amazon, you can't put it on the cloud. So there, if you need some data that's on a blockchain with medical records, then the join has to happen within your firewall. So that's the kind of use case that we're envisioning in the next couple of years. There's a lot of, I would say, the amount of dark data, the amount of private data is actually a much, much more than all the public data combined together.
Super interesting. Yeah, that sounds like really cool use cases and something that has been done before for sure. I think, yeah, I wanted to like one basically final question maybe from me. I think one thing that I find interesting maybe is, we talked about right inflation, the staking mechanism, how the participants are incentivized, at least on that supply side. And then we're saying the demand side will pay for it. But is there also like certain incentivization for people to actually use the API? Or is that just, okay, their product relies on this data, they're going to use it? Or is there like some way how you're like trying to encourage that more? I think you also mentioned the hackathon. So I guess anything you're kind of doing to incentivize that, may it be economically or also just like hackathons, I would be interested to hear how you're trying to like.
Great question, and the answer is yes. So let me talk about the API for a bit. So we have these Class A and Class B endpoints. So Class A endpoints is like wallet balances, transactions, transaction receipts, token holders, like all of the public data for any token, right? Class B are specific to a protocol. So you can go get like Uniswap on Optimism, Uniswap on Ethereum mainnet. You can get like Pancake and all those like specific to a protocol, right? We are actually going to be opening up a new product called to create Class C endpoints. So this does not exist today. So you can go in and you can contribute your own endpoints. So it's not just the Class A and Class B endpoints. That's all been built by our team internally at Covalent, right? The Class C endpoints is not only a consumption-based model, but also a contribution-based model. So now this will be like an app store, and you get a portion of the query fees if your endpoints are queried. So our vision here is to get all of the long tail assets, all of the long tail data, all of the long tail use cases captured. And there's no way for Covalent to handle that in-house, right? When we started in 2019, there was only 5 DeFi protocols. So we created these Class P endpoints for the 5 protocols. Super simple. By 2020, it would become like 50. 2021, it had become 500. I would say by end of this year, it'll be like 5,000, right? And there's no way for us to create 5,000 endpoints. It doesn't make any sense, right? It doesn't scale. So for us, it makes sense to take a step back and create the tools so that the protocols or anyone from the community can create these endpoints and they can earn a living out of it, right? So we're opening up this marketplace. So I think that's a pretty exciting thing that's been long asked for by the community. They want to contribute their own endpoints. They want to be part of the Covalent like data model and the whole environment. So that's what we've been prepping up. This is a big change in our architecture and like everything that we do. And there's a big go-to-market program there, because just because you build something, it's not going to get traction on day one. You actually have to teach people. You have to have hackathons. You have to have, the right kind of guidance, incentive models. So all of that, the whole shebang, right? That's all going to be coming in for the Class C endpoints. So stay tuned for that. That's going to open up. I think we have like 50 endpoints right now. I think this time next year, we'll have probably 1,000 endpoints, right? All coming from the community.
Super cool. Yeah, that I think is like one thing that always seemed like, when I personally was thinking about Covalent, maybe that was like something that was a bit missing, where it seemed like, okay, you're building this one API, which is very nice, right? One API, billion possibilities, or whatever the slogan basically is, right? I think, does that kind of change this model, or is it still like all these Class C endpoints would also kind of fit in that giant spreadsheet idea that Covalent has? Is that still the same?
Yeah, because it's still the same. It's the 1 billion possibilities, right? There's the long tail of use cases. Like you hear all kinds of crazy use cases today that there's no way we can create API endpoints. It just makes sense to open up the platform, right? And it's taken us a couple of years to get there, but I think these are decade-long projects, right? They're not like a DeFi protocol where you deploy a contract and you find millions in TVL overnight. So this is a little more like, this is infrastructure, requires expertise, requires scaling, requires like finesse when it comes to engineering. So that's what we've been working on, pretty diligently over the past. By the way, I don't know if your listeners know, like we're a 60-person team. So there's a number of us. More than half of us are engineers. So we are just shipping code day in, day out. Doesn't matter, bear market, bull market, we'll continue to ship.
And with that,
awesome.
Thank you so much for coming on the show today, Ganesh. It's been truly fascinating, I guess, to hear your journey so far. How you built out your vision for Covalent, how unique the product is in the crypto market itself. We're really excited to support Covalent, of course, which will be going fully live and decentralized with 4 node operators, I believe, in upcoming weeks, as you mentioned, maybe in Q2. So perhaps we might leave it, if anyone wants to check you out personally, Ganesh, your socials, and also Covalent's, where can they find you and Covalent?
Absolutely. So the Covalent website is covalenthq.com. And our Twitter handle is covalent_HQ. We're very active on socials. We're also active on Discord. For developer help, go to Discord. Validator, any kind of stuff, go to our network page. My personal Twitter handle is Ganesh with a 5, so GANE5H, which was a great idea when I was a teen, and I've continued to keep that around. And I'm generally very responsive, right? So my DMs are open. So DM me if you have any concerns, any feedback on the product, any feedback on our vision, or just want to chat. I keep my DMs open for a reason. So please reach out. That's basically it.
Perfect. Thanks so much for coming on the show, Ganesh. And yeah, see you again soon, mate. Thanks very much.
Thanks, Felix. Xavier, thank you so much.